everyone, today I Payal Arora is going to present on the topic characteristics of good hash function and different keys to address transformation techniques before you all. First of all, let us see the definition of hash function. It is a function used to place data in hash table. Similarly, it is also used for retrieving data from hash table, and therefore use of hash function is to implement hash table. Now, let's come to the characteristics of a good hash function. The first characteristic is the hash function should be easy to compute. Number of collisions should be less while placing the record in the hash table. Ideally, no collision should occur. Such a function is called perfect hash function. Hash function should produce such keys which will get distributed uniformly over an array. The hash function should depend on every bit of the key. Thus, the hash function simply extracts the portion of a key that is not suitable. Now let us see some of the key to address transformation techniques. There are various types of hash functions or hash methods which are used to place the elements in hash table. They are division method, multiplication method, extraction method, and mid-square method. Now let's see these methods in a bit detail. First, we will come to the division method. The hash functions depends upon the remainder of division. Typically, the divisor is table length. For example, if the record 54, 72, 89, 37 is to be placed in the hash table, and if the table size is 10, then when we first divide 54 by 10, the remainder is 4. Therefore, it is placed at the position 4. 54 is present at position 4. Similarly, it is for the other numbers or 2. Now, the second one is the multiplicative part. Before that, we have to first take the first step, that is multiplying the key k by a constant k where a lies between 0 to 1. Then extract fractional part of ka. Then we have to multiply the fractional part by m and take the floor. The above steps can be formulated as h of k equals to m of k into a, where k of a is the fractional part. Donald Nutt suggested to use a equals to 0.618033. That is the constant. Now let's take an example. Let key k equals to 107. Assume that m is equal to 50 and constant a equals to 0.6180. Now h of k equals to m into 107 into 0.618. Now 107.0 into 0.618 equals to 66.12. Now let's extract the fractional part, that is 0.12. Now h of k equals to 50 into 0.12, that is equal to 6. That specifies that h of k equals to 6. That means 107 will be placed at index 6 in hash table. The advantage is that the choice of m is not critical. Now let's see the other method. The other method is the extraction method. In this method, some digits are extracted from the key to form the address location in hash table. Suppose first, third and fourth digit from left is selected for hash key. That is, from the number 497824, 4, 7 and 8 are selected. At 478 location in the hash table of size 1000, the key can be stored. Now let's move on to the other method, that is mid-square method. This method works in following steps. The first step is square the key. The second step is extract middle part of the result. This will indicate the location of the key element in the hash table. Note that if the key element is a string, then it has to be pre-processed to produce a number. Now let us take the key as 3111. Now when we square 3111, the number obtained is 9678321. Now we extract the middle part 783. That is, for the hash table of size of 1000, h of 3111 is equal to 783. Now let's move on to the last method, that is folding. In folding, there are two folding techniques. First is fold shift and the second is fold boundary. Now First, let us see fold shift. In this method, the key is divided into separate parts whose size matches with the size of required address. Then left and right parts are shifted and added with the middle part. Let's see the example of fold shift. Here a number 3, 4, 5, 6, 7, 8, 1, 2, 3, that is a key, is divided into three parts. The left and the right part are extracted and they are added to the middle part, that is 3, 4, 5 plus 6, 7, 8 plus 1, 2, 3. Now the number obtained is 1146, from which 1 is discarded. Therefore the index of this number is 146. Now let's see the second method, that is fold boundary. In this method, the key is divided into separate parts. The leftmost and rightmost parts are folded on fixed boundary and added with the middle part. Again, the same number is taken as a key, that is 3, 4, 5, 6, 7, 8 and 1, 2, 3. Similarly, as in the previous example, the middle part is extracted. But the first, that is the leftmost part, and the rightmost part digits are reversed. That is, they have taken 5, 4, 3 of 3, 4, 5 and 3, 2, 1 of 1, 2, 3 and have added them to the middle part, that is 6, 7, 8, which becomes 5, 4, 3 plus 6, 7, 8 plus 3, 2, 1 is equal to 1, 5, 4, 2. The first number, that is 1, is discarded. Now the index becomes 542. These were some of the key to address transformation techniques. Thank you.